Let's start with this exercise of trigonometric identities. In trigonometry, trigonometric identities are equalities that involve trigonometric functions, and they are true for every value of the occurring variables for which both sides of the equality are defined. In this exercise, we need to eliminate theta between the given equations. Now, how do we do that? When we have to eliminate trigonometric functions, the only way to eliminate them is to replace them with identities so that we can ultimately substitute 1 in place of the identity. Now, to arrive at identities, you have to carefully think about the operations that need to be performed on the given functions. Let's learn more of it while solving the exercise. For example, this question says x is equal to a cosec theta and y is equal to b cot theta. This implies that x by a is equal to cosec theta and y by b is equal to cot theta. Now, what identity accommodates both cosec theta and cot theta? Well, it is 1 plus cot square theta is equal to cosec square theta, which implies that cosec square theta minus cot square theta is equal to 1. This also means that first we need to square this, then we have to square this, and then subtract the 2. So, let's go. Squaring both the sides of x by a equal to cosec theta. Let's call it 1. Now similarly, squaring both the sides of y by b equal to cot theta. Let's call it 2. Now subtracting 2 from 1, we get this. And we discussed a while back that cosec square theta minus cot square theta is an identity and its value is 1. And here we are, theta has been successfully eliminated. Easy, right? Let's move on to the next one now. Question 2 says x is equal to a cot theta plus b cosec theta and y is equal to a cosec theta plus b cot theta. Please note that in this question also we have the same trigonometric functions, that is cot theta and cosec theta. And we know the trigonometric identity around these two functions is cosec square theta minus cot square theta is equal to 1. Hence, we need squares of cosec and cot theta and then their difference. So x square equal to a cot theta plus b cosec theta whole square, which gives us this. Similarly, y is equal to a cosec theta, y square equal to a cosec theta plus b cot theta whole square, which gives us this. Now subtracting both, we get x square minus y square equal to this. Solving it, we are left with x square minus y square equal to this. Now, let's bring a square cot square theta with a square cosec square theta and leave the other two to one side. Now we can take a square common and we would be left with cot square theta minus cosec square theta. Similarly, we'll take minus b square common and we'll be left with cot square theta minus cosec square theta in the brackets. So, we know that cosec square theta minus cot square theta is 1. Therefore, cot square theta minus cosec square theta would be minus 1. Substituting here, and we get x square minus y square is equal to b square minus a square. So, theta has been eliminated. Moving on to the next one. This one is a little different, so pay good attention. Here, x is equal to a sec cube theta and y is equal to b tan cube theta. Now, the identity that shows the relationship between sec theta and tan theta is 1 plus tan square theta is equal to sec square theta, which implies that sec square theta minus tan square theta is equal to 1. Let's try to achieve this. Now we can say that x by a is equal to sec cube theta and x by a raised to the power 1 by 3 is sec theta. Now squaring both the sides give us x by a raised to the power 2 by 3 equal to sec square theta, because we ultimately wanted to reach at sec square theta, right? So let's call it 1. X by a raised to the power 2 by 3 equal to sec square theta. Let's call it 1. Similarly, y by b is equal to tan cube theta, we are given that. That implies that y by b raised to the power 1 by 3 is equal to tan theta, and then squaring both the sides we get y by b raised to the power 2 by 3 is equal to tan square theta. Let's call it 2. Now to arrive at the identity, let's subtract 2 from 1. We would get this. As we know, sec square theta minus tan square theta is 1. We get this. And hence we could successfully eliminate theta. Moving on to the next one. X by a cos theta plus y by b sin theta is equal to 1. X by a sin theta minus y by b cos theta is equal to minus 1. Now identify for sine and cos. Identity for sine and cos is sine square theta plus cos square theta equal to 1. That means we need squares of sine and cos, right? Let's square both the sides of both the equations, which gives us this. We get this. Let's call them 1 and 2. Adding both the equations, we get now taking common wherever possible, we get this. Using the identity sine square theta plus cos square theta equal to 1, we get this. Thus, we get this, thereby eliminating theta. Moving on to the next one. Here x is equal to h plus a cos theta and y is equal to k plus b sin theta. So again, we would use the identity sine square theta plus cos square theta equal to 1. We can say that cos theta is equal to x minus h upon a and sin theta is equal to y minus k upon b. Squaring both, we get, now adding these two equations, we get this. Now sin square theta plus cos square theta is 1, substituting, and we get this, thus eliminating theta. Next is, we have to prove that if cos A by cos B equal to m and cos A by sin B equal to n, then we have to prove that m square plus n square times cos square B equal to n square. Let's square both the equations. We get, on adding these two, we get this, which further gives us this. Taking cos square as common in numerator, we get, now replacing sin square B plus cos square B with 1. Now we know that cos A by sin B is n as given. Thus we get this and hence this, which is what we need to prove. Moving on to the next one. We are given that x is equal to a sec a cos b, y is equal to b sec a sin b, and z is equal to c tan a. And we have to prove that x square by a square plus y square by b square minus z square by c square is equal to 1. Let's get the elements on the left hand side. So x square by a square, we get sec square a into cos square b. Similarly, y square by b square is sec square a into sin square b. Now z square by c square is tan square a. Adding first two equations and subtracting the third, we get this. Now taking sec square a common, we get this. Now cos square b plus sin square b is 1. And the second identity, sec square a minus tan square a is also 1. Hence, this is what we needed to prove. Hope you understand it well. Let us know your feedback, and if there is any question or exercise that you want us to solve, please comment it below. Have a good day. Bye-bye.